Okay, so now we're going to do our distance time graph notes in our journal. Also known as a motion graph. When we do this, you have to remember some things. Motion is what? What did we say motion was yesterday? It's a change in your position. Good. A change in position. And how do we measure it? What's the y-axis? Distance and time. Measured by distance and time. Now I'm going to switch colors so that you can see it better. We need to know what speed is. What speed? What speed? What is speed? What does it tell us?
Speed is acceleration.
No. It tells you how fast you're going. It's a measure of how fast you're going. And how do we do that? How do we calculate it? Speed equals. What does speed equal?
What's it equal? Distance divided by time.
Very good. Speed equals distance divided by time.
That's pretty cool.
Okay? Miss Arp wanted to learn about it too. I don't have any. You'll have to ask Miss Hussey. But you can make coffee right there. Okay, velocity. I know it's a lot of words, but velocity is simply the speed and direction. For example, if I said I'm going 60 miles per hour north, then that's velocity. Pretty simple, right? To me, it's just as easy to say, tell me your speed and direction. But whatever. Acceleration is changes in speed or direction. When we say acceleration, we usually mean speed up. Okay? If I say accelerate your car, I usually mean speed up. But I'm going to use a different shade of blue right here. And I'm going to write deceleration. Deceleration. I hope I spelled it right. That means to slow down. I'm going to look at and make sure I spelled it right. It's 1C. Accelerate is 2 C's, but decelerate, DECELE. I didn't say I was the spelling bee winner. Okay, so let's talk about how we plot it actually on the graph. I'm gonna go with purple for a minute. If you draw just simply a box like this, not a box, angle, it's a 90-degree angle. Okay? This is the x-axis. And we learned about this in math already. The x-axis tells us the time. This is the what? Y-axis. And what does it tell us? The distance. That's why we call it distance over time. If you remember distance over time, then you'll always know that the distance goes on the y-axis. And we can calculate speed. Time is always plotted on the x-axis. Do you hear me? The further you move this way, the more time is passing. Okay? Tell me some ways we can measure time. What units could we use to measure it?
Hours.
We could measure it in hours, which would be HR. What else could we use? Seconds, which they put S, but I put SEC a lot of times. Minutes. I didn't mean to put my parenthesis at the beginning of it right there. Don't worry, I'll fix it. MIN, minutes. Okay? We usually do hours, minutes, or seconds. Okay, what about distance? How would we measure our distance? Kilometers, right? Which is km. Or instead of using kilometers, what do we usually use in this country? Miles, M-I-L-E-S, which is M-I. In your car, your parents' car, it'll have miles and kilometers on the speedometer. It'll have both. You could do meters, which is M. That's what we usually use when we're looking at distance time graphs. We usually do meters per second, or you could do meters per minute. You could do miles per hour or kilometers an hour. I hope you're not going miles a minute.
That'd be like more. So you have to go like 120 miles an hour.
This is recording right here, so your mom can watch it back and hear that you said she drives fast.
I didn't say that.
No, she did.
Oh, she did. She went to Mississippi by herself.
Okay, stop with the sidebar conversations about parents driving. Now, I'm going to go ahead and flip this page. You can look back in a little bit and get it. I want to do some example graphs and talk about what's going on. Okay? So, here's the first one. What goes on the side up here? Distance. And what goes on the bottom? Time. So, I'm just going to draw a couple down the side here. Distance over time. Distance over time. Distance over time. I drew 4 down the side of the paper. What? Right there. Now I'm going to draw a line on here. And I want you to tell me what that means. Raise your hand if you know what that line means on that first graph. Homer? No. No what? No motion. It doesn't matter where it is on that graph. It could be down here, up here, anywhere in between. That means no motion. Okay? What about that one? It's not flat.
A small increase.
It's a small increase. So what does that mean? Is it the same throughout? Yeah, that's as straight as I could draw it. Okay? It's a straight line. What does that mean? If it's a straight line going up, I hear music. If it's a straight line going up,
Constant speed.
it is a constant speed, but what kind of constant speed is this one? How fast is it going? Slow. What about this one? Is it also a constant speed? That's a constant speed. Raise your hand if you want to answer. Give everybody a chance. This one's faster. Okay, so let's run a little test right here. I'm going to draw 3 lines. That green line is supposed to be straight. Pretend it's a straight line. I don't feel like getting out a ruler. Which one's the fastest? I should see hands up everywhere. We should know. Which one's the fastest, Jocelyn? The which one?
The middle one.
The middle one's the fastest? Are you sure? The purple one is. Look how steep it is. Let's call that line A. Now the orange line's longer, but that's because it took it a longer amount of time to get to the same distance, didn't it? We'll call that line B. And the green line, line C, is the slowest one. You got it? Now I'm going to come about to the middle of my page here and I'm going to draw some more. If you're at home at any point, you can just pause this video to be able to copy down what I have. Okay, here we go. What is that? It's an upward curve. What does that mean? Deceleration? Are you sure? I started out going slow and then what happened? I went faster. Look, I'm going over a farther distance in a shorter amount of time. Right? This is acceleration. Not deceleration, acceleration. Speeding up. I'm going to show you what deceleration looks like right now. You're going pretty fast, and then you kind of fizzle out. This is deceleration. Or slowing down. Here's how you tell the difference, Aiden. And I know it's not just Aiden that needs to know. A flat line's no motion, right? The flatter it is, the slower it is. See how flat this starts out? It starts out slow, but then it starts going up. That means it's going faster. This one starts out going up, so it's going faster, but then look how it starts to slow down and get flatter. Does that make sense? Okay. What about this line?
A major deceleration.
What do we call that? Look which way it's going. What do we call it when a line goes back down to the line like that? No. Remember, if I walk over there and then it's returning to start. I'm going back because down here's 0, isn't it? I'm returning to the start. Now, here's the example. We saw it in the PowerPoint. This is steady. This is no motion. This is return to start. But what if I come in here with a line like this? That would be an acceleration. I'm not going to put anything else on there because I don't want to gob it up. Right, Zig? Me and Ziggy refuse to let it get gobbed up. What happened, Bryson? What happened?
I just hurt my leg.
Oh. Thought you was raising your hand. Any questions about this?